Hello everyone, I'm Siddharthan. Currently, we are in the 8th module of our hands-on machine learning course, and in this 8th module, we have discussed about the topics such as cross-validation, hyperparameter tuning, grid search CV, randomized research CV, and so on. And the next topic that we will be discussing is model selection. So model selection is all about choosing the right machine learning model for our problem, and there are a lot of different factors that has to be considered while performing this model selection. So in this video, let's try to understand what are all the different factors that influence this model selection. Okay, so once we understand this, the next video will be an hands-on part where we will try to implement this model selection technique in Python, where we basically try to compare the performance of different machine learning models. Okay, so let's get started with today's video. And first of all, let's start with what is meant by this model selection. So as I've told you, model selection is machine learning is the process of choosing the best suited model for a particular problem. Selecting a model depends on various factors such as data set that you have, the task that you wanted to do, and the nature of the model itself. So these are all the different things that we have to consider. So like when we say best suited model, it is the model that gives you highest accuracy, or in the case of regression problems, it is the regression model that gives you the least error. Okay, so we can call that particular model as the best suited model for that particular data set and that particular use case. And again, so this model selection depends on what kind of data that you have and what is the task you are going to perform. So if you are performing classification, we know that there are classification models are there. If you wanted to perform clustering, again we have different clustering models and so on. So these are like few factors, so we will go in detail about these factors. And again, as I've told you, there are like two factors should be considered while we are performing this model selection. The first thing is, what is the logical reason in order to select a model. So why we have to choose a particular model in a particular case. So we will discuss about this first one in today's video, and the second one is about comparing the performance of the models. So this is what we will try to do in Python in the next video. Okay, so it is just comparing how different models are performing for that same data set. So how we can do this comparison in Python. So we will focus on the first part in this video, and we can move on to the second part in the next video. Okay, so when we talk about this model selections, models can be selected based on like two important factors. One is the type of data available, and the next one is the type of the task that we need to carry out. Okay, so if you talk about the first one, which is like selecting the model based on the data that we have. So usually when we have image data and video data, we use CNN. So CNN stands for convolutional neural networks, and convolutional neural networks are known for image recognition and this computer vision tasks. And again, so video is nothing but they are like several images that are present in frames. So like videos are nothing but they are basically images. So for image data and video data, so we like CNN are the best suited models. And when you have this text data or speech data, in that case we use RNN, where RNN stands for recurrent neural network. So all these things comes under deep learning part, and we will discuss about the CNN and RNN in the deep learning course. And we will also be working on several deep learning projects along with this machine learning course. So in that you will understand so how the CNN works, so how we can use them, and how the RNN works, and so on. And generally, like when it is numerical data, we go with the machine learning models like logistic regression, supported machine decision trees, and so on. So it is not that we can apply only machine learning models with numerical data. We can also use neural networks as well for numerical data. But so generally, we will go with machine learning model itself when the data is like simple, like like numerical data. Whereas if you consider image data and text data, the data is kind of complex, and it is there is like a huge amount of data has to be processed and has to be learned from. So that is why we move with deep learning for this image and text and speech type of data with deep learning, and work on this SPM, logistic regression, and these kinds of simple machine learning models when it is numerical data. And the second like based on the task, how we can select the model. So if we talk about this, so classification task, we use the models like support vector, machine classifier, logistic regression, decision trees, etc. So we know that classification task, we will try to classify the data point into different classes or categories. Okay, so logistic regression is a pure classification model, so you cannot use it for regression. So it as this name called as logistic regression because it is developed from linear regression. So that's why this has the it has the name logistic regression, but actually it is used only for classification. Whereas if you consider a support vector machine, so support vector machine, it has both classifier as well as regressor. Again, so we also have models like random forest classifier, which can also be, we also have a regressor based on random forest. So like most of the models can be used for classification as well as regression, but logistic regression is mainly used for classification. And another important thing is logical regression is widely used for binary classification problem. Binary classification in the sense when you have only two classes or two categories. It's not like every time you will get best result, but if you have a linear data and if you have a binary classification problem, in that case logistic regression kinds of works best. Okay, and if we consider support vector machine, it kinds of works well when the dimensionality of the data is high, when you have several number of columns in your data set. So in that case support vector machine is the best suited model for your work. And regression task. So if we talk about regression task, we have models like linear regression. So we also have random forest regressor and so on. So we also have like support vector machine regressor. But so in general, random forest regressor kinds of gives you better results because it is an ensemble model and it is like widely used. So we have linear regression, random forest regressor, polynomial regressor, and so on. So apart from this, you have KNN classifier, KN regressor as well. So these models are also there. And if the task that you are performing is a clustering task, so obviously we have to go with k-means clustering and hierarchical clustering. And these are unsupervised learning models where we don't need labels at all. So these models will try to group the data based on their similarities and so on. So these are like two important things that you can consider. So if so the thing is, you can choose your model based on the data that you have and based on what is the task that you wanted to follow. So these are like few factors upon which you can select your model. So apart from this, you have to understand about the advantages and disadvantages of all the models in machine learning. So once you understand this, it will give you a clear picture of which model to use when. So I'll just take three models and explain you how we can do this, and you can do the research on other models. So we cannot go through all the models that we have. I'll just show this for the three models that we have. Okay, so we know that linear regression is a very simple model and it is used for linear regression tasks. Okay, in other words, the regression problems. So the advantage of linear regression is like it is very simple to implement, and the main advantage is it performs well on data with linear relationship. Linear relationship is in the sense like if the x value increases, the y value also increases. If x value decreases, the y value also decreases. So there is only a linear relationship between them. So you can consider this t as x and y as it can be y. So if you see this curve, there is no a linear relationship between them. So it is kind of a sine relationship, right? So like this is the curve you get for a sine function. So when the data is this kind of a function, so in that case we cannot use linear regression, so it cannot capture that trend in the data. Whereas if you have linear relationship in the data, in that case linear relationship, linear regression works well. So that is the main advantage of linear regression. So you can understand this the linear relationship using the correlation matrix. So once you build this correlation matrix, you can put that in an heat map to understand whether there is some linear relationship within the data, within the different features and so on. Again, so if you think about the disadvantages, it is not suitable for the data having non-linear relationship. So when there is when there is no linear relationship in the data, when you use linear regression, you will get the results won't be good. So there will be like high error values. So we kind of try to avoid this linear regressor. Linear regressor is a very simple model. Okay, so we don't use it that much, but it's better to understand about this. Again, so it has this underfitting issue and sensitive to outliers. So this is another important factors. If your data has several outliers, then it is best to not use a linear regression, because like linear regression models are sensitive to outliers. So the function that we create using this linear regression is affected a lot by the outliers value. So we have to consider these things. So so if you think about different models, so this is how you can evaluate on which model to choose. So you have to take into consideration both the advantages and disadvantages of a particular model and what is the data that you have. So if you have a linear data, it is not like that much complex and you don't have any outliers, you can go with linear regression. So you have to consider all these factors and you have to come to a decision. And if we talk about logistic regression, so we use it widely, and again, so it is a very easy to implement model. It is like a very basic model in machine learning, and it is actually actually like built from linear regression. Okay, so we take the linear regression function and we apply the sigmoid equation. Okay, so that's how we get this logistic regression model. And yes, this logistic regression also performs well only on the linear relationship data, and again it is used only for binary classification problem. It can't be used that efficiently for multi-class classification or regression problems. You cannot use it, but for binary classification problem where the data has a linear relationship between them, in that case we can use logistic regression. It is a very good model. And so if we consider about disadvantages, like if the dimension within the data is very high, in that case logistic regression won't perform well. So there will be this overfitting issue. Dimension in the sense when you have when the number of columns is very high in a data set, so in that case logistic regression won't work well. So you have to look at the data and see whether okay, whether we can use the logistic regression in this case, or I have to go with subprotected machine or random forest classifier and so on. So if the dimension is more often subprotected classifier used, because like it kind of works well on high dimensional data. So that is one thing. And again, so if like this logistic regression, it is difficult to capture complex relationship. Again, it is based on linear regression, so it works well only on the data set which has linear relationship between them. Again, this is sensitive to outliers, and it needs a larger data set. So small data sets, it cannot capture the trend properly and so on. And this is the last model that I will discuss. So remaining models, you can do your research on what are all the different advantages that you have and the disadvantages that you have and so on. I just wanted to give you an idea of how you can look at this advantage and how you can select the model. Okay, so if we talk about decision tree, it can be used for again both classification as well as regression. And it is like easy to interpret. So we have this decision nodes, or what we call as so we have the branches and we have like two nodes, and each node like will have two outcomes. So it can be like yes or no, and if the answer is yes, it will go to one branch. If the answer is no, it will go to the other branch. So we have seen this in decision tree intuition video and so on. I hope that you have seen that video. So like it is like easy to interpret and understand how this decision tree works, and like no need for normalization or scaling. So normalization is when we try to convert all the columns so that all the values are in the same range. So that is what we call as normalization. And we have this scaling, right? So what the standard scaler does is it will try to bring the data to a normal distribution. So that's what the standard scaler does. So when we are working with the regression model, we have to do this normalization and scaling, whereas for the decision trees and random forest model, so if we want, we can skip these steps, because these tree based models can understand the data without normalizing or scaling. And again, so these are like not sensitive to outliers compared to the regression model. So if you like, this is like a very important thing. Like this particular question can also be asked in interviews as well. So they would ask like which model is not sensitive to outliers. So the correct answer would probably be tree based models, whereas regressors are greatly affected by the outliers. So the linear regression, lasso regression and so on. So these decision trees are not affected by outliers. So if you have a data set and there are like several, like a few outliers are there, so if you don't want to process the outliers, you can directly use the models like decision trees or random forest. But if you want to use a regression model, you have to process this outliers before using them. So this is like the other thing that you can consider while selecting the model. So if we consider about the disadvantages of this decision tree, so it has this overfitting issue where you will get high accuracy for training data, but the accuracy on test data will be low. And again, small changes in the data may alter the tree structure, causing instability. Instability means like you may get different results, because like if the values are like changed by a small factor, then the result will change by a huge factor. So that's what I mentioned by this second disadvantage. And the third main disadvantage is the training time is relatively higher. So the amount of time the model takes to train, and when you take a new data point, and if you want to predict the label for the new data point, it is going to take a somewhat longer time compared to the other models. So this is something that is like very crucial, because if you have a data set that has 500 data points or 1000 data points, that's not an issue. But if you have a data set that has like, let's say, a million rows, in that case, if you're going with the tree based models, it will probably take a very long time. So these are like different factors that we have to consider, and this will help us to choose the best model for our particular use case. So I have just discussed about these three models. I'm not going to go deep into the other models. So I suggest you to please do some research on the advantage and disadvantage of all the models that we have in machine learning. So this will give you a clear idea, and it will help you in a long run on how to choose the models, and which model is suitable for which case and so on. So this is about the different factors that contribute to selecting the model that we have in machine learning, but this is not all. So in the next video, as I've told you, we will be working in Python, where we will try to build something where we will try to automate this process of selecting the model. So we will basically process the data set, and we will feed this same data set to different models, and we will check like what is the performance of the different models. So performance in the sense, we will compare their accuracy scores or their error values, and we will choose which is the best model. So these are like two things. So first you have to consider or you have to choose the model based on your logical understanding of the machine learning models that you have. And the next step is, so scrutinizing few models. Let's say that based on all this advantage and disadvantages, you have a particular data set and you are coming up with three machine learning models. So out of this three machine learning model, you have to choose only one ML model. So in that case, we can go to Python. So we have to train all these models with the same data set, and we have to compare the results. So this is how we usually do the model selection. And I hope that you have understood all the things covered in this video, and I'll see you in the next upload. Thanks for watching.